Hey everyone. Okay, this is Joanne again. We're back to the engineering education lesson and we're in part two. You remember that part one was all about selecting a major. And now we're looking at the part two, which is evaluating engineering programs to see how they fit with each of you individually. So I'm going to share my screen and I'm bringing us back to the engineering education module where the first section, part one, was selecting your major. And now part two is evaluating academic programs. So we're going to go through a few different things on this video. And the first thing is a file that shows you a graph. Now, let me open that up. So first, whenever you look at a graph or a table that's giving you data, you always have to look at when it was made. So if we look down below, we see, oh, this is admission rate for 2012-13 based on 2012-13 data. It's more than 10 years old, right? So you think, okay, it's not worth anything. Well, they haven't updated the data, and talking to all the faculty at Cabrillo in engineering, we all think it's still the same. It's still in the same good information to share. So we're still sharing it. So when you look at a graph, I always look at the x-axis first, and the x-axis says admission rate. So here is a 10% admission rate. Here's 100% admission rate. So a school that would be posted here would be one that would be more selective. They don't accept that many students, where at the other end of the x-axis, these are schools that accept a lot of students that apply, okay? And the y-axis is 20-year average annual return. And we could look at, this is data from 240 institutions in the United States. It's all American universities, right? And we're looking at, when they say 20-year average annual return, it's like people who graduated in engineering, whatever other major is on this graph, they've asked them, what was your return for your investment of going to that school? So it could be weighed, there's not specific criteria. If I was being interviewed, I would weigh it based on how I feel, how successful I feel I am, and whatever success means to me, how happy I am, maybe my quality of life. So there's not certain criteria. It's based on the individual alumni. So let's take a look at it. The blue dots, which they gave you a line for it, was based on if you have a degree in the arts and humanities, and the red line represents engineering, computer science, and math. So you might think, okay, well, why are alumni who get degrees in engineering, computer science, and math ranking their average annual return higher than arts and humanities? My feeling is they probably have a better quality of life because their salary is higher, they are able to afford a house, and et cetera. So then what we're looking at, so we know that engineering, you make more money than arts and humanities, and you could have a better quality of life if, I don't know. I mean, I'm not trying to place such importance on money. Okay, then you look at blue. You look at the blue line, and notice that there's a slope to this. It means that people who have degrees in arts and humanities, it's really important for them to go to schools that are more selective. And the alumni from schools that aren't as selective aren't rating themselves as high. But what do you say about engineering, computer science, and math? Let me just give you a moment to think about it. What would you say based on this hardly any slope? That it doesn't really matter where you get your engineering degree. Because whether you go to a selective school, like Berkeley might be over here, maybe Chico State's over here, but it doesn't really matter. You're going to have a great job, and you're going to have a great salary, and you're going to have a great quality of life. And why does the school not matter? And you might, in class, I have students throwing out things like, oh, well, the curriculum's the same. Yeah, overall, the curriculum's the same. But really, it's about supply and demand. There is so much need in the United States for engineering majors. There are so many jobs out there, so many opportunities that it doesn't matter where you went to school. And if you find that, let's say Chico, the teachers are awesome, let's say, and the faculty is working on projects that you really like, it would be better to go there because it would be a better fit school for you than maybe going to a Berkeley where maybe you don't, the faculty aren't working on projects that you're excited about. Okay. So the point of this graph is really to say, find a school that fits you and you would be happy at, because you're going for engineering. It doesn't matter where you get your bachelor's degree. Okay. I'm going to close this and I'm going to move on to the second thing. The second thing we're going to look at is accreditation. Okay. So on the engineering education module, there's a link for a bet, like you're placing a bet on something. And here is the website. So I'm going to click on the website. And ABET stands for Accreditation Board of Engineering and Technology, Accreditation Board for Engineering and Technology. So what does that mean? It's a national organization that comprises working engineers, CEOs, engineering faculty, deans, a bunch of folks that go out to each engineering program at a university to decide whether they feel that they should be ABET accredited or not. So what does that ABET team do? They look at the facilities, they look at the equipment, they look at the textbooks, they look at the exams, they talk to faculty, they talk to students. They just look at everything and then determine whether the program is ABET accredited or not. So this website is a great tool for you to find programs that are accredited. Okay, so let's play with that a little. Search ABET accredited programs. And there's two ways to do a search, an institution search or a program search. So let's do institution search and let's put in Cal Poly. And you may know that there are 3 Cal Polys now. There used to just be Cal Poly San Luis Obispo and Pomona, but now Humboldt turns into a Cal Poly. Notice right now we're only linked into Cal Poly Humboldt, and they only have one engineering program that's accredited. Although they started a mechanical engineering program, it's not accredited yet. It has to have one graduating class before they could get reviewed. And looking at Cal Poly Humboldt, notice when is the next comprehensive review? It's in 28-29. So in 28-29, ABET's going to come to Cal Poly Humboldt, review their environmental resource engineering program, and review their mechanical engineering and whatever other engineering programs they have then. So you're going to see that in 2029, this list will be longer because Humboldt has started mechanical engineering and will start others. But let's just go to Cal Poly and let's look. So they have an aerospace engineering, agricultural, systems management, which is really not an engineering program. So I'm not going to put it on the list. Okay, but it's been ABET approved. There's architectural engineering, biomedical engineering, bioresources and ag engineering, civil engineering, computer science, separate, which, and even though computer science is called science, it's not a science. Like they don't study laws like gravity. They're really designing things. So for computer science is really engineering. And then electrical engineering, environmental engineering, industrial, manufacturing, materials, mechanical, and software. So if I counted it right, there are about 13 fields of engineering, departments of engineering at Cal Poly that are ABET accredited. So this is really a great way of determining which schools you might want to go to. So often we have students who are majoring in environmental engineering. So instead of doing an institution search, let's try a program search. And let's type in environmental engineering. I probably don't even have to type it. Let's look. Okay, so let's just do it. Notice there's one that says technology, right? Remember, I talked about that in the part 1 video. Technology means they're training technicians. It's still a very great opportunity to get, but it's not the same as an engineer. It's a little lower. I'm going to stick some filters on it. I'm going to pick a bachelor's degree, and I'm going to pick United States. And I'm going to pick, let's pick California. Okay. And now it looks like, wow, there are 8 institutions. 7 institutions call their degree environmental engineering, and 1 institution calls itself environmental resource engineering. We already saw this one. This is Humboldt. Okay. So they're more focused on air and water, their environmental resources. But let's look. So there's 7 programs in California that have ABET accredited environmental engineering. So Cal Poly San Luis Obispo, UC Davis, UC Irvine, UC Merced, UC Riverside, San Diego State, University of Southern California. So if you want to get a bachelor's degree in environmental engineering and you want to stay in California, those are your choices. That would be my suggestion because they're ABET accredited. When you have a lesson in a few weeks on engineering employment and professionalism, you'll learn about becoming a licensed engineer. I'll just speak about it for a moment. The fields of engineering that require licensing is fields where you're designing something where if there's a failure, a lot of people die. And that's typically civil. So in civil engineering, civil, structural, architectural, engineering, you're all going to become licensed. And one part of getting licensed is to have gone through an ABET accredited program. If you didn't go through an ABET accredited program and you went to a different university that wasn't an ABET, a program at a university that wasn't ABET accredited, your degree doesn't count and you have to work another 4 years before you could sit for the licensing exam to be a licensed engineer. I want to remind you that, doctors have to get licensed, lawyers have to get licensed before they could even practice medicine or law. As engineers, we don't have to get licensed. We could work as engineers before. But in the areas where they require licensing, which is civil engineering, I imagine anybody who's designing planes, that somebody has to be licensed. Then you need to take exams and get licensed. But like I said, you're going to learn more about that when you in the professionalism class. Okay, so let me go back to the module. And so the first one was where to get your BS degree, and that was the graph we looked at. The next one was the accreditation board. The next one that I want to look at is engineering education. I'm going to talk about a lot of characteristics of different university programs in terms of engineering. So I need to stop sharing first and then go back because I want to share a PowerPoint. Okay. So I'm going to talk about characteristics of different types of engineering programs out there, because the goal of this part 2 of this lesson is for you to determine the type of university you want to go to. Okay. So the first slide, now all the photos happen to be our Cabrillo engineering students because that's what I have the photos of, but I'll discuss different types of universities too. So no matter where you go to get an engineering degree, you're going to have labs associated with classes. This is from the materials class. This is from the surveying class. This is from the circuits class. And these 2 are also from the materials class. So no matter where you go, you're going to have labs. So you're going to have some hands-on. However, there are some types of schools that design in the curriculum is really important. So at Cabrillo, we have engineering design in every single class. This was from the materials class. This was from the statics class. This was materials and this is statics. This was a water balloon shooter. This was a 3D bowling ball maze. This was making musical instruments out of innovative materials. And this was a walk on water project. So let me say, all universities in the senior year, you will have a senior design project that's called a capstone project. So no matter what university you go to, you are going to have a big project in your senior year. However, there are universities that are more hands-on, and you're going to have lots of projects in lots of classes. And then there are schools that are more theoretical, that you're going to not have any projects until your capstone. So, for instance, the California State University is really, their goal is to train you to start working as an engineer. So all their classes have design projects in it. So whether you go to Cal Poly or San Jose State or San Diego State or Humboldt, you're going to have projects as you go along. If you go to a UC school, UC Berkeley, UC Merced, they are more of a research focused theoretical school. And one thing I'll say about them too, well, no, I'll talk about that when we get to the courses later in part 3. So if you're more of a hands-on person, you want to go to a school where you're going to get hands-on design experience. Now, if you're a Cabrillo student, you're going to get tons of hands-on experience the first 2 years. So it really doesn't matter where you transfer to, because you have had a lot of design experience that you could write on your resume. And then if you go to a UC, well, then you'll have the capstone project in 2 years. So it's kind of fine. I'm more concerned about those of you who are high school students that may go to a school where there's no real hands-on stuff. Okay, so let me keep going. But if you're a really more theoretical, sciencey type, then you might want to do research. And there might be more opportunities. There will be more opportunities to do research at a UC than a CSU. And research is more working in a lab, studying things, testing things. All right, let me go on. Okay, engineering design could also be called project-based learning or service learning. So a regular design project, you're just designing a project. It may be for a purpose or not. It may just be a school assignment. But when you're doing a service learning project, you're really designing something that's going to be used by the community in some way. So for instance, these students here and these students here designed some hands-on projects for, there's a children's discovery museum in the Capitola Mall. You probably went there when you were little, 3, 4, 5. Parents might have taken you there. Well, what they did is they designed these hands-on things for kids. So it was project-based learning in that they were learning doing a project, but it was also service learning because they were serving others. And there are some universities that are more geared towards wanting to serve others. In our program at Cabrillo, we call engineering as a helping profession. We design prosthetics and things for the environment, for people. So we feel like engineering is a helping profession, so we do service learning. Let me go to the next slide. All universities have maker spaces now, so you don't have to worry about that. You're going to get them. Student support. Almost all universities have tutoring for math and science, definitely. Because a lot of kids going straight to a 4-year school don't do well the first year, so they really want to keep them. So they're offering a lot of tutoring services. But how many schools have study centers where you could work along other types of students on projects, and they have free computers and free tutoring in there, and faculty have their office hours. Like this is the STEM Center at Cabrillo. When our students leave, they say at the university they don't really find as great of a STEM center or a study center. Okay. Next slide. This is an opportunity that you could have after you finish taking a class. You could be a paid tutor or TA in classes. And that's really awesome, especially when the course is within your major. For instance, if you want to be a materials engineer, when you take the materials engineering class, you could ask the faculty member if you could be a TA for the next year. You get to learn the material better. When you tutor, you get to understand the material better, because when you have to explain it, you understand it better. So you might want to look for places where there are opportunities to work as tutors and TAs. And you probably want to go to a place where they have engineering clubs. This is the Women in Science and Engineering Club. This was the Engineering Abroad, where we went to Costa Rica to work with a village on a project that would be called service learning. excuse me, and this is the robotics club who's won so many national awards. So look for schools that have engineering clubs. There are some universities that offer engineering, but they have so few engineering that they don't have any clubs. And clubs are a great part to be involved in. They usually do some huge projects. So, okay. Okay, engineering abroad, I already mentioned. The opportunity to go to conferences. We took a bunch of students to Seattle for the Society of Hispanic Professional Engineering Conference. We went to the American Society of Engineering Education Conference in Washington, D.C. I'm taking, Kelly Archer and I are taking students to the Society of Women Engineers Conference in New Orleans this coming October. So that's a really neat opportunity too. And then we go on tours of engineering facilities. We have at Cabrillo, we have so many alumni that have gone through Cabrillo's engineering program because Cabrillo's engineering program started in 1961. So it's been around a long time now. And we have thousands of students who went through our programs and are working as engineers now. So a lot of times we'll set you up with alumni, especially in Engineering 5. And that's really a nice thing too. And then we have internships with, we're networked, and you want to make sure all universities are pretty networked with their local industry to set up internships and have research experiences. Okay, so if I go back to the top, if we're looking at characteristics of schools, that are you kind of a hands-on person? Do you want to do design in the curriculum as you go through? Are you interested in designing things that are going to help people, service learning? Is there a study center? What's the study centers like where you choose? Is there an opportunity to be a tutor, a TA? Are there a lot of engineering clubs? Do they have an engineering abroad program where you could go away and work on a project with a village? Do they take people to conferences? Do they sponsor you, give you money to go to a conference? Do you go on tours? Are there mentors who are working engineers? Do you want internships, research experiences? So these are the type of characteristics of some universities. Okay, I'm going to stop sharing. I'm going to go back to my module. And then now this is really an amazing database of information. This stands for, which you probably know already, American Society of Engineering Education. So there are many technical societies out there, right? ASCE, civil engineers, ASME, mechanical engineers, IEEE, Institute of Electrical and Electronic Engineers. There's AIAA, Association, no. American Institute of Aerospace and Aeronautics. There's a bunch of technical societies. Well, as an engineering professor, I belong to ASEE, and what they do is they do a lot of research about different schools. And I want to show you, we're going to look at that, but I want to look at this one first. This is old. It's from 2019, but it's data that I think you'd be interested in seeing. And we're going to go to page 27. So let me open that. Okay. So their data each year is called Engineers by the Numbers, and I'm going to go down to, let's see, 27. Look, 27. Ah, it doesn't want to erase. Why not? Okay. Okay. So, this is old, and we don't need to look at this because we're going to look at this as new data. But what I want you to look at is this. So they're looking at data that goes from 2009 to 2018. Okay. So let's say a freshman went from high school to a freshman to a university. And how many students were engineering? This is all engineering only. And this is only American society, so it's only US. So it's we looked at all the United States universities that offer engineering, And in 2011, there were 123,000 freshmen. So when they went to the next year, they would have been sophomores and it would have been 2012. And look at the number. So what happened? About 12,000 students dropped out of engineering. And why did they drop out? Typically, the reason they drop out is that they were probably really good in high school, but they didn't have to study too much. They get to college, they're not doing well. They're only taking math and science classes, no hands-on engineering yet. And they realize, you know what? I don't like this. I'm not going to be a good engineer. And they drop out, which is so unfortunate because the demand for engineers is so great. And it's not relied on what your grades are. It's relied more on the skills that you develop as you go along. So it would have been great if in freshman year they had design classes where students got a feel for what engineering is, and it would push you through the classes that are more the science and math that might be a little bit harder. Okay, then what happens? These sophomores go to junior year, and all of a sudden now we have 8 more thousand. Why? Well, why are now there more students? Reason? People are coming from a community college. They're transferring. They took their first 2 years at a community college first, and the numbers went up. But what's really amazing is when you go from junior year to senior. So it jumped from 118 to almost 75, 119 to 175. That went up, about 60,000, 55,000. So what's that all about? Okay, 2 things. One, when you transfer from a community college, you might have more units than you needed because when you first came to a community college, you might have taken a bunch of different classes to figure out what your major is. And by the time you're ready to transfer, even though you're transferring as a junior, the university thinks of you as senior status, which is great because you get to register early. But you're not really a senior, you're really a junior. So you're going to stay there another year. Also, the second reason is it hovers between 5.2 and 6.2 years to get a bachelor's degree. Even though an engineering bachelor's degree is considered 4 years, most students don't get out in 4 years. They're there 5 years. So there's actually another year, and they're called super seniors, but they didn't want to put a 5th year. So that means that some students are seniors twice. Okay. So I think these statistics are pretty helpful to know about. And for some reason, they stopped producing it in 2019. So that's why I kept it in here. Let me go back to the module. So I kept the 2019 stats here, but let's go to the stats that are more current. So that is right here. So when I get on this website, they're even showing you the 19 stats, but I didn't want to go this way. So we can look at the 23 stats. So let's see. Profile engineer by the numbers. And let's look at the table of contents. Oh, so these are all the universities that participated. So it's 223 universities participated in 2024 for the 2023 data. And now let's take a look at the table of contents. So they have information about a bachelor's degree, a master's degree, a PhD, and even faculty, but we're only going to look at the bachelor's. So they're showing you the total number of bachelor's degrees awarded by engineering discipline, awarded to underrepresented minorities, awarded to women, which universities gave the most degrees, what are the bachelor's degrees awarded by gender. There's so much data in here. So let's see, let's just go down and look at one of them. So we can look at this and see, oh, okay, on the x-axis, it's all the degrees in engineering. And on the y-axis, it represents the thousands of students. So you could see that mechanical engineering is the most popular engineering major, with computer science as the second most popular. And there's when it says computer science outside engineering, it's typically a university that does not have an engineering program. Like for instance, what's that school up? I can't think of a specific school right now, but there are liberal arts schools that don't offer engineering, but they offer computer science. But what's funny about those is that because it's a liberal arts school and they're only offering computer science, there really isn't a lot of clubs and hands-on work there. Okay, then civil and electrical almost tied. Okay, let's see what else. There's okay, Institute awarding the highest number of engineering bachelor's degrees. What is this saying? Georgia Tech is has a huge engineering program. They offer almost 3,000 degrees in engineering. Purdue, and this is all, remember, bachelor's degrees. Purdue is huge. Texas A&M is huge. Let's look at one from California. There's Cal Poly. Cal Poly, by contrast, offers 1,400. So this stuff, they just give you a lot of really cool data, which again is kind of giving you statistics of engineering. Sorry, not statistics. Yeah, they're giving you statistics of engineering programs, and in a way, they're giving you characteristics of their program. So let's take a look again. Under the module for engineering education, the second part was evaluating engineering academic programs. And we looked at the slide that showed the table. It doesn't really matter where you go. We looked at which programs are accredited. We looked at engineering, that PowerPoint that showed characteristics of engineering education in the 21st century at universities. We looked at the data that's in here. And the last thing is looking at college and university characteristics. So I have an activity, but I'm going to have you do the group activity when you're in class with me, but you're going to do the individual one. So let's open this first. So what I did is I toured a lot of universities, not just in California. I went California, Arizona, Colorado, Washington State, Oregon, Massachusetts, Indiana, Pennsylvania. Anyway, not all of them, but I went through a bunch of engineering universities that have engineering. And what I did is I took their characteristics and I broke them up into 3 areas. The first one is geography. Second one is social demographics. And the third one is curriculum. So if you look at geography, like, do you want to be in a city when you go to college? Do you want to be in a small town? Do you want to be near city life? Do you want to be near Santa Cruz, or how far? Do you want to go to a school that has 4 seasons or no 4 seasons? Are you okay if it gets cold? Are you outdoorsy? What is the campus layout? Is it all spread out? Does it have like a community campus feel? Like, these are things that are characteristics of universities that you could use to decide which of these things are important to you. Then I also have a category of social demographics, and you could read through this, right? Is there housing for all 4 years? Like, do you want to be on campus all 4 years? Do they have sports? Is sports not interesting to you? Frats, interesting or not? Is it a small or a large school? How many students are there? That's going to affect the social demographics. Okay. Is it a school? What's the percentage women at their engineering school? Is it 20% or is it 50%? There are schools across the country that really have diversity in terms of male and female. And how about ethnic diversity? These are all things that you can look at and determine whether they're important or not to you. Okay. And then the third category is curriculum. Are they ABET accredited? Do they focus on undergraduate teaching? How are the teachers? Are the freshmen doing design? Is there a makerspace, a machine shop? What are the faculty projects? So these are all things that affect your curriculum. And then I said, tuition is also really important, and how much merit aid or financial aid can you get? Merit aid is is scholarships based on your academics, where financial aid is based on your how economically disadvantaged or advantaged you are. Okay, so I'm gonna close this one and I'm gonna go back to this assignment. So here is the characteristics, a thing. And then here's the assignment. It says individually, each of you are to spend 5 or 10 minutes reviewing the list above. Then make a list of the 10 to 15 most important characteristics of a college university. These are considered the criteria that you'll use that you must have the school you go to. For instance, if you're willing to be in a city or a small town, do not put that on your list because it doesn't matter to you. But if you only want to be in a big city, then put a big city on your list because that's going to be one of the criteria. So in the end, you should have a list of 10 to 15 things that are most important for you in a school. Okay. So in the homework assignment for the engineering education, you're going to be listing these 10 to 15. I think I asked you for 15 things in the homework assignment. So you could look back at the accreditation. That might be something important to you. You might look back in this the PowerPoint slides that I showed about service learning and things that were important. You could also look at things in engineers by the numbers. What data is there that's going to tell you what's important for you? And then you're going to look at these characteristics. Okay. So I'm going to stop sharing now and I'm going to stop the video. Okay. I hope this is really helping you. Okay. Bye. And I'll be back for part 3.